Today we're going to talk about finite differences. So the learning goal is how do we recognize the quadratic functions based on the finite differences? If you remember, finite differences or first differences, you've learned about this in grade 9 for linear relations. And if the first differences were the same, essentially the relation would be a linear relation. So first differences are calculated by subtracting consecutive y values. Now in grade 10, we're going to go to second differences, which are calculated not by subtracting the y values, but by calculating the subtraction between consecutive first differences. Okay, let's see how that looks like. So we're going to start with a table of values. As you can see, you have 1, 2, 3, 4 different quadratic relations. I'm going to start with this one. So negative 4 squared is 16, negative 3 squared, 9, 4, 1, 0, 1, 4, 9, 16. Now, when we talk about the first differences, we look at the y value. So y value is basically y equals x squared. So this column would be the y values. So we're going to subtract them, but we always have to start from the bottom to the top. So 16 minus 9 equals 7. Then I have 9 minus 4 equals 5. 4 minus 1 equals 3. 1 minus 0 equals 1. 0 minus 1 equals negative 1. 1 minus 4 equals negative 3. 4 minus 9 equals negative 5. And 9 minus 16 equals negative 7. So if we look at the first differences, are they the same? No, they're not. They're different, which means this is definitely not a linear relation. So then we go to the second differences and we take the values of the first differences and we're going to subtract these ones. So this will be 7 minus 5, which is 2. 5 minus 3 equals 2. 3 minus 1 equals 2. You have to be careful here because it's 1 minus negative 1, which is actually positive 2. Negative 1 minus negative 3 is positive 2. Negative 3 minus negative 5, again, equals 2. And I have negative 5 minus 7, which equals 2. So basically, this is how we find the second differences. Now, what I want you to do is I want you to do the same thing, the table of values for 2x squared using the same x values. So 2x squared here will be 2 times negative 4 squared, which is 32. 2 times negative 3 squared is 18, and so on, okay? And then calculate the first difference, then calculate the second difference, then do the same for negative 0.5 x squared plus 3. Remember, for these more complex situations, we use BEDMAS, so we do the exponent first, then we do the multiplication, and at the end we do the addition. So once you do all this, what I want you to do is answer these questions. What is the direction of the opening? Is it up or down? So we've learned this in lesson 2. If the coefficient of x squared is positive, the direction of the opening is up. If the coefficient is negative, then the direction is down. Then is the first difference constant? What does constant means? Constant means, is it the same? Yes or no? Is the second difference constant? Yes or no? And then what is the equation of the line of symmetry? Okay, So that's all you need to do for this table, and then answer these questions. Then if you go on the other side, what I want you to do is do example number 1, which is the exact same thing that you just did, but you already have the x and the y values. All you have to do is basically find the first differences, find the second differences, and see which ones are the same, the first or the second. That's it.